Hey guys, it's Josh with Project Blue Smoke Monster. I want to first start off by apologizing. It's been a while since I've been creating content. Things have been busy. I've been going through a number of things. A lot of that supply chain related, and kind of stalled this whole project out. But I actually recorded this months and months ago, and the folks at PCBWay were so kind as to provide some boards as a result of the design that I'm going to show you here. And I never had a chance to produce the content because I couldn't take the project forward because I couldn't get the parts. That is beginning to resolve itself now. So I want to go ahead and bring this back to life. I want to show you that what we're going to look at in this video is a prototype power supply that I created and then did some testing on some of the elements for. And I actually had PCBWay do an assembly service on it for me. And when the thing showed up, we were able to get into it and learn a lot as we develop the final power supply for the Microcontroller Trainer. So why don't we ride along, jump in here, and take a look at the process of getting that board order put together with the schematic and the assembly, the bill of materials and all that stuff, and submitting it to the boardhouse. I think a lot of you might find that useful. There's some tips and tricks in there that you can use. And again, thanks PCBWay for hanging in there and sponsoring the boards, and we'll get to it. Holy crap, did it just desolder itself? I think it's desoldering itself. One end of the coil goes to the antenna connector, jumps to the diode. The diode is our audio path, and this comes out to the headphone. One of these days I'm going to fix the squeaky chair on the screen. So if you want one of this rev, it's available to ship now. Oh yeah, can't do that here. Can't do that here. Gotta do that in the other cart. Boy, I've got that heatsink hot. Like hot. Like feeling hot. I mean, this is not going to be a showstopper that stops me from developing this. If I got to deal with a line of garbage for this badass capability, I'll deal with a line of garbage. And the Microcontroller Trainer is a learning environment, experimentation environment, development environment. You come up with what you want to call it.
Hello everybody, my name's Josh and this is Project Blue Smoke Monster. I apologize in advance for the way I sound. You can blame my mother. No, I'm kidding. I've been sick the last few days. This is a Wednesday night, I think. And I've really been under the weather since Friday. Really haven't left the bed much in the last few days. But the show must go on. The project must continue. With a little bit of luck, I'll be returning to work tomorrow. Yes, I sound much better than I look. I've got a face for radio, ladies and gentlemen. So, wanted to get into some final stage prep on the power supply before we send it to the boardhouse. So I've been exchanging some drafts with the boardhouse. They've come back with some feedback, and we're going to make a few changes. We're actually going to omit a few components that we were going to have them pre-assemble for us due to largely lead time. There are a few cost considerations, but largely it's one of lead time. Some of the things that I can get a little more quickly than they can, I'm just going to go ahead and assemble here. Piece of cake, right? No big deal. So as we take a look at where things have landed, I'm going to pull up a few documents here and we'll take a look at things. And I'm also going to share a little script that I put together. In fact, we should put this up on GitHub. Maybe we'll do that tonight. A script that I'm using to create the bill of materials for PCBWay in particular. They released a new tool recently that I guess is undergoing some modifications still. before it's completely ready for prime time. But one of the promises of the tool ultimately is going to be one-click board submission. So you're going to take your bill of materials, you're going to take your your centroid file, your parts positioning information, as well as your Gerbers, straight up and into your shopping cart. That would save me a little bit of time, so something I'm interested in. But the bill of materials piece is not quite ready yet. So I went and I wrote or modified one of the existing KiCad 6 bill of material scripts to create a file in a format that was compatible with PCBWay that they could interpret with ideally no modification. And I think we've achieved that. So it only took me about an hour or so. So other things I'm thinking about, test points, a little expensive. I may change what I'm using there. Don't know yet. Thinking about it. Just kind of thinking through things. So parts that we're going to omit temporarily. That's right. I said I was going to upload or open a bill of materials. Let me go do that. Let me go find the file. Browse. B drive. KiCad projects. Trainer PS reprise. Trainer PS. We're going to look for all files. And this is going to be a CSV. Trainer PS CSV. So the first thing I want to show you is this document. This document is an add or an as generated, as submitted, and as accepted bill of materials for PCBWay. The script that I was just talking about actually created this, and this is based on the format that PCBWay says they want. So item number, that's just some counting. Designator, that's the part name. Quantity, that kind of goes without saying. The manufacturer, we've identified manufacturers for most of these parts. I'm not so sure that PCBWay substituted their locally available generic parts. So maybe I need to put in the notes here, okay to substitute. Even though I ticked the little checkbox, I'd like them to use a 5-cent part if they can do it instead of a 20-cent part, obviously. And, when we're getting into, the caps I'm using, for example, I don't care if it's made by Samsung or Kemet or if it's a multi-comp part. It doesn't matter to me as long as it meets my ratings for the purposes of this prototype. So that's something I'd like to do. But this is the output that we created from that script of mine. So that's pretty cool. We go into KiCad, and I'll show you where I'm setting the values at for that. So we go in, let's look at it in the schematic view, and let's pull up this tabular view of things. This shows all of the fields that are attributes to the part. Now, one of these I want to talk about is datasheet and why I'm not using it. So most of these go without saying, reference, value, footprint, MPN. MPN's a field that I created, and you can create a field just by adding a field, giving it a name, and now that attribute is available across all of your parts. Well, when it comes down to it, these scripts are actually pretty straightforward. Let me go ahead and open the script that I'm using. Actually, can I? Hey, RJ. I actually may not be able to show that to you tonight because I think I wrote it on my laptop and I don't think I've saved it out to the network yet. I think it's just local on that machine. But I can still show you the defaults that come with it. So let me open one of these here. I'm looking for it here. I'm not seeing it. I'm gonna have to check something here. Tools, generate BOM. KiCad 6 bin scripting plugins. Okay. KiCad 6 bin scripting plugins. Okay. So this is a Python script that's being used by KiCad to generate a bill of materials. And this is pretty basic stuff. All the real magic is happening here and here. So this bit of code is essentially writing a header that has some base information. And you can see the functions that are being called to get this information out of KiCad. And you can see the columns that are existing in this. This is ultimately becoming a CSV file. So you can see the columns that are in there. So what I did is down here, we looked at what are they doing on the line. So this is kind of writing the header, and then we go into for all of our components, and we kind of loop through it all. So all I had to do was change the headers to align with the format here that PCBWay wanted, and then play the fill in the blanks game. Well, this last example made it super easy because it showed me how to reference a field based on an attribute name. So for me to reach in to custom attributes that I've created was quite trivial. And let me show you some of the custom attributes that I've created. MPN, that is a custom Josh tribute. We're going to call this a Josh tribute. It's a custom attribute I created, and it contains the manufacturer's part number. I've got a name called short footprint that I'm using to put a description of a footprint in a format that I would like to use. That's a custom attribute. Type is a custom attribute. URL is a custom attribute. Now I tried to access the datasheet attribute, but I must be hitting a bug because when I accessed that attribute, some older stale data was in it and not the current data from this. So they must have had a nomenclature change on the back end. So rather than swimming upstream and fighting that, I just created a field called URL and threw my value in there. But essentially, we just modified that script, and down here, changed it. Sorry about that, I'm still sick. Changed it to pull the field names that I wanted. And Bob's your uncle. There's your bomb. So, sorry about that. I'm trying to mute myself while coughing, and my mic didn't want to come off of mute. So that came in handy, and we were able to submit this bill of materials to the boardhouse. Now, they came back to me with some feedback, and I'm going to find some of that real quick here. Let me find it. BOM reviewed. Back. Here we go. So I got this back from them. And basically what they did, they took my data, which is conveniently formatted the same as their data, kind of made it easy for them, and they came back to me with unit prices and the normal things you'd need to know to do an order. Now, a couple of things, like here was an out-of-stock part. Here's an out-of-stock part. Out of stock, price change. We were getting into some, potentially long lead times here. 3 business weeks for some of this stuff. So I think what we're going to do is, find substitutes, which I've done. Find substitutes and kind of get this all ready to go. Now, much of that I've already done, and I've decided to drop a few things off of here. So let's take a look and see for sure where we've left this. So, yeah, so what I'm going to do, we're going to go save as, whoops, wrong one, get back here, nope, here, okay. We're going to call this, come on, give me a dialog box. Save as, trainer PS, call it condense. Parts removed. That'll work. Bomb with excess parts removed. So we'll pare this down to things that I'll either choose to supply or things that we will let them just not assemble. So the battery cell. Let me think about that one. In fact, let me get their dock open still. They want $5.38 a piece for those things, and they want 10 days to deliver it. So we're going to go ahead and omit that for now. We'll just delete that from the list. There we go. The little fuse had some lead time issues, so we'll delete that. I have some of those on hand, so that's not a problem. This is the Phoenix connector. I've got those on hand, so we'll delete that one. The switches, those are out of stock. I happen to have an alternate source, so I'll delete those. To your point, Bald Engineer, the test points, the pads are more important than the part, so let's get rid of the test points for now. The TTGoT display, I have some of those in my own personal inventory. And I think that is largely going to resolve things. Barrel jack, I've got some of those too. So this kind of shrinks the component list a little bit. And I believe resolves anything. They had a problem with this SS34 Plus, and they think it's called an SS34A. Yeah, exactly. If they have something that fits for 5 cents, that's great. But otherwise, when we get to production, that'll be a whole nother bill of materials massage. Designed for a manufacturer. We've tried to do some of that here, but if a part's not available when we go to production, I'll probably omit the part or choose something else. But if I've got a couple in inventory, how much work is it for me to solder a little fuse on? How much work is it for me to solder a couple of shunt resistors on? It's no big deal. Okay. So this looks all fine. And I was pretty happy with the component prices they had on things. They were sane and reasonable. So let's double check this. The SS34 Plus. I know that's its part number, but let's see what Octopart has to say about that. Let's bring the Octopart over here. Let's look at in stock, lowest price. I mean, I'm sure these are pretty much all going to be the same thing. 11 cents. 25 cents. It's just a Schottky diode. Let's go SS34A. Multicomp SS34A, 25 cents. Here's a Hot Tech. SK34A, SMA. Let's go with this multicomp. Yeah, SS34A. I'm good with that. Whoops, not that. SS34A. For the manufacturer's part number. Okay, so that's cool. I like it. Are there any other issues? Any other things that we need to pull off of this? I don't think there is. I think we're in good shape here. So let's save this. I wanted to go to KiCad, make a couple of other minor tweaks to the layout before we send this. The first thing I want to do in the schematic is I want to add on the 5-volt output here an empty pad for a Zener diode. It likely won't be in the final build, but I'm going to throw it in there anyway. And actually polarity on that doesn't even matter because we're not going to be populating it. I just want the footprint there. So that should we want to, we can put it there. Not connecting, come on. Don't be a piece of pooey. Connect. What the frick? What's my grid at? Okay, there we go. And then we're going to bring that down to ground. And like I mentioned, this is purely so that I have a footprint. Well, my grid originally I thought was a 0.127, but we've made it smaller now. So we can link things up there. That should be fine. Let's go out to this. Let's edit the footprint of this thing. Okay. And we'll just put it right there. Like I said, that likely won't actually be used. In fact, I have a better place to put it. Sorry about all the coughing, guys. There we go. And that'll go to ground. Should be good. Okay. Other things that I've done. You'll notice that I made the pads on this footprint oval. They were previously round and just a little tough to solder to. I've been finding lately that if I make oval pads for through-hole parts, it's just that much easier for people to solder. People in this instance being me. Doesn't want me to be able to move that much. Whatever. That looks fine. Other changes that we've made. The boardhouse advised me that these particular through-hole vias that we use for thermal could be, they were 0.2 of a millimeter. And they said if you make them 0.3 of a millimeter or bigger, that the cost will go down. And the cost went down significantly. That was a surcharge category. So that is fine. We just modified the footprint in place. We talked about test points already. Are there any other changes I want to make to this bad boy? Not too many. Let's go release candidate 1. Let's see what else we can put on here. Let's just have some fun with it. Okay, nice. And that's getting to be about the right size. Yeah, that puts it on the back, right? Let's see what that looks like. Bink. Bink. Yeah, that's cool just for funsies. Just for funsies. Do we have a KiCad footprint we can put on there? Bet we do. So great. Cool. That's nice. And let's check one more thing out here. Let me go get a file here. Things are not opening where they're supposed to be opening. Okay. And since this particular board, unless they come back and give me a hard time, is likely to be sponsored, we're going to put a little logo on it. They did not require me to do this, but this is just a little fun that I'm wanting to have to learn graphics placement a little more. like I said, I'm not required to do this. Just having fun. Load bitmap. And let's just leave it normal size and see what it looks like. Export to clipboard. That kind of worked. It didn't take everything. What's a footprint? Front silk screen. Let's play with some black-white thresholds. Export to clipboard. Yeah, see, that way it picked that up. Okay, cool. And we can actually change the ratio. Let's go 20 millimeters. This is actually making it really easy to move logos over. It's a little grainy, but considering what we started with, that's not terrible. No, I certainly use JLC for a lot of my boards. I know different people have different preferences on board houses, and I think that's a healthy thing. It's nice to have some competition, so we makers have choices. Yeah, I think we're just going to go do that. Boom. Is it out of my clipboard? There we go. So design with KiCad. I like that. And then let's add a little text. Front silk screen. PCBs manufactured. Actually, we'll say supplied courtesy of oops, undo that. Move that back down. Move this up. What's she look like? I think that looks pretty nice. I think we're there. I think we're ready to send it. So recent changes for those of you who didn't catch, every recent stream. We added a power switch. I added a little fuse, a poly fuse. I verified all the footprints. I spun these LEDs at 45-degree angles because they look sweet. I made the pads on this oval so that it'll be a little less of a pain to solder. Wouldn't hurt for me to do it on those too. But that's all fun. Fun and games, right? I think we're ready to send it. All right, so let's do this. If I click the little one-click tool here, it opens for me in a new window this. So it created a zip. It sent the board. I may have to be logged in for it to actually render the Gerber, but it's been doing that previously. It says I'm signed in. Let's go to the cart here. Yeah, that was all checked. Let's remove. Okay, let's do this again. We'll leave that open. One click. Yeah, that's interesting. And maybe it just needs a minute, but it was showing me Gerbers in there before a render. So we do that, and then we go. I'm gonna. Actually, we're good on the bomb. So the assembly service. We want 5 pieces. And actually, what do we have here? We're saying make 5. I don't really need 5 assembled. What if I just say 3 assembled? Does it minimum me out? That's 35.42. 5. It looks like it's a price break of 5, so we might as well just do 5. Okay. Do you accept substitutes? Absolutely. Topside assembly, turnkey, they'll supply parts. They'll handle all this. That's all good. We'll save to cart. And then for the assembly, we'll grab the bomb. That's the one we worked on tonight with the excess parts removed. And you'll see it took it. I'm going to need to do the Centroid file. Okay, well, I guess I'll export a new one. Fab outputs, component placement, CSV. Single file for board. All right, Trainer PS, all pause CSV. Here's the file. So we've pulled them, and we'll say submit order now. So they're going to review this. They're going to come back. They'll quote. It'll be ready to go. Right now, we're looking at $5 for the boards. We're looking at an assembly cost of $30. Components cost will be quoted, but that's fine. We can close that. So I'll go in here and check in a few hours. I believe they're at work right now. So yeah, we'll make sure we hit save. But I think we're ready. If this works when they show up, just as is, we will be at the next step, which is uplifting this onto the trainer board itself. Now, I'm not sure. I'm a little torn on how to do that. I can either make it one board, or I can make it modular. If I make it modular, I'm going to have to come up with a connector that I like to mate the two boards together. Now, there's nothing on the back side. However, we do have some through-hole parts here protruding. So those are some things to think about. We could put it on standoffs. Yeah, that would work. And maybe that's the right solution. And then layer it over the board. Standoffs are permanent enough that it's not going to be weird, but temporary enough that it allows for some flexibility and enhancement in the future. So that's probably the direction we'll go, is standoffs. Yeah, I'm digging it. Digging it. I'm super excited, guys. I think this is going to work. I think it's going to be good enough anyway. All right. So that's off to the boardhouse. Fantastic. So what's next, Will? I'm glad you asked. Let's look at the big project, PCB. So here's where she looks like. And it's pretty much what you would expect. That power supply mock-up is going to show up, up here in the upper right. I think I know what we're going to do tonight. Yeah, so this stuff is going to definitely change. But, yeah, I think, so we'll just leave that to spin out for tonight. I think what we're going to do is we're going to try to get some software going for the power supply. Let me get a few things in position on the bench, and we will see about doing some pretty stuff with an IPS display. And we may, I really hope, for that matter, we may be able to locate some of the previous code that I was using, as to not have to reinvent the wheel here. All right, let's get this all to where you can see it. Let me change the view. So we have that, and then we have the power supply. And what we really want to stare at is that. So let's get a good zoom in on that. Nice and beautiful. And let's throw a battery into the power supply. Good. We'll plug in the power supply. Good. Which should show that microcontroller powered up. Let's find out if it does. Let's see. I want a different view. How about we do this? And let's get into Arduino. Loading. And what we're going to look for open recent. Get started? Yeah, that's for the 3221. What we're going to look to see is if we're getting any data out of this thing as far as the voltage and current utilization. Okay, that's booting. So we are connected. That's good. And our code was getting 115200 data. Good. So the question becomes, is it getting voltage? So my voltage, so there's my rails. And actually my rails should already have voltage on them. It shouldn't take much to get this going, actually. 40, I think, is the address. Let's upload this. I think the code we're running has a different address than what we're usually using. So we'll get that in place here and see if this starts spitting out what we want to see. And if it does, we're going to get into code and try to make this thing look pretty again. Floor one. Oh, I think it's 40 GND. I have to change the pin name here. See if that works. And if not, we'll look it up. This was, what, about a week and a half ago I played with this, so. Oh, wrong board. Tools. Board. This is a ESP32. ESP32. Dev board. Where is it? I don't have them in Boards Manager. I've had a problem with that here recently, disappearing. Okay, well, let's fix that. Let's fix that. I'm going to go grab the Board Manager URL. ESP32 Arduino. And it's just the Boards Manager URL that I need. Excuse me. We can close that one. Go. Preferences. I think what's happened is that it's crashed out. and not saved the changes. But we'll fix that here real quick. Okay, ESP32, and I know you guys aren't seeing this. That's not... Oh, wow, I got really old code. So 106 installed, 202 is out there. Wowza. Well, yeah, by all means, let's update it. Let's see what we break here. I get a couple of Raspberry Pi Picos here that I had just arrived. I haven't really done much with it yet. Started soldering the headers on it. Curious to see how those work. We're going to use one as a programmer for another kind of thing. Come on, do your thing. I guess you guys can watch that. We're just kind of waiting on Boards Manager. I'd really considered rolling my own ESP32 for this, but for $10 a board, man, that's just hard to beat. As long as availability doesn't become an issue. Now, you might say, why do you need an ESP32? Why just not put that little IPS screen on the trainer board and throw a, ATmega 328 on it or something? Well, I can't get them. I'm looking at what's in inventory and what can I actually get. Plus, the complexity of a flat flex connector getting soldered on at the board house and then double stick taping the display. We're getting into more manufacturing requirements there that I'm not really ready to deal with yet. Okay. Board ESP32 dev module. COM11 looks right. We're going to upload our code. Let's cross our fingers. I'm going to be counting on all of you guys to order 100 of these each when they come out so that the Kickstarter funds and we can get these into people's hands. If I only get exposure and 10 pre-orders, it's probably not going to fly. I'd like to see 1,000 of these sell in the first batch. That's really my kind of go, no-go goal. I don't know whether it's going to happen, but I'm hopeful. Hey, there we go. All right, so we're getting voltage and current. And it's not showing us amperage, but it's measuring it. There's just not a load on it right now. So let's work with this. And once we get that displaying, we can work with getting some other measurements. But for the sake of starting, I think that's good. I think that's a good place to be. So, time to write code for our deal. All right, sweet. Screen looks formatted well. We can work with this. Okay. So the next thing to do, pretty code for a pretty display. We've got to figure out where my original code went. This could be interesting. Well, I'm going to start searching out here in an old folder and see if I can find the old project. Let's see here. Trainer. See, it's not going to be KiCad projects. It's going to be in the Arduino folder. Okay. Okay. Meter emulation. I think these are going to be things with dates. 2020, February 1st, 2020. Let's see what that sketch had in it. This ought to be interesting, finding old sketches and seeing which one has the logic for this. This had absolutely useless code. Okay. We can delete that sketch then. February 1st, A. Let's look at this January 1st one. RGB LCD shield. We'd hear you should use Git. Well, you know what? Git's great, but you want to know what's even better? Actually naming sketches and saving them in meaningful folders, because a lot of the time I don't. It's just whatever I did that day, and it takes the default file name of the date. Oh, here's some IR stuff. So it's not that. A simple project name would have helped. This is all IR stuff. That's some NFC stuff. Ooh, ooh, ooh. I might see something. It says Trainer MD, but I don't remember what MD stands for. But it does say working base code. All right, let's do this. Let me evaluate what you guys are seeing. Yeah, that'll work. We can make this slightly better. There we go. Let's upload this. Oh, wow. That was when I was using that. Parts of this may still be good. Okay, so I'm going to say that's probably not the right sketch, but I think we were in the right location. Oh, yeah, buddy. I think we might have found something useful here. Because that include is right. Upload. Let's see what happens. Okay, ST7789. I don't remember. Oh, that must be the display. ST7789. Let's open that up. Because it took a little work to get that display doing things. And unless I've captured it here, some of it may be lost to the ages that I'll have to rediscover and relearn. Because let's face it, clearly this was a year ago. And we may not even want the display to look like I had it mocked up back then. I may want to do different things. But I want to get back to that starting point anyway. Compiling, let's see if it'll run. $13.31. Okay. Don't know why I need that, but we'll put it in there. Good old messy code of Josh of yesteryear. Compiling sketch. No. Okay. Seriously, it's gone again. The ESP32 is gone again. All right, hang on. I do this. I'm going to close Arduino entirely. So I think I have something going on there. You guys saw me install the ESP32. Now the board definition was gone. I think I might have had multiple Arduino instances open and confused it. Let's see if we can find out. Yep, that was it. It's fine now. Okay. Let's look out here on the B drive. Arduino. Trainer MD. Work in progress. That's better. Much better. Upload. Come on, buddy. Show me some voltages. Uploading. Ooh. Look at that. That's the code. That's awesome. Okay. Not just numbers either, real data. That is actual data. That display right there is why I'm so fascinated with this module, with this particular microcontroller. That's just gorgeous. Let's go in here and correct some things. Pull that over here. Bring this way. All right. Okay, so it's channel 1, channel 2. So 3v3. So we're going to make that channel 2 because that's how I wired it. We'll make this channel 1 because that's how we wired it. That'll fix what's in the columns. We'll let that upload. It is now compiling. And that should now have the data in the proper columns when it boots. Yep, that's correct. That's exactly what's going on. That what I'm calling the 5-volt rail is currently at 6.09 volts. The 3.3 volt rail is at 3.30 volts. And we show the correct current consumption, which right now is nothing. Now, if we want to put something on that rail, we can give it a nice load. And we'll watch it tell us some numeros. Let's go ahead and load down that 3v3 rail a little bit. Okay. Let's get ready for this. I know you guys are getting excited. This project is starting to feel a little more within reach than it has at sometimes in the past. But that's part of getting there, is that the journey takes time. Just ask Steve Perry, right? Okay. Okay, cool. That's one of the clips I need. Actually, the 5-volt rail is the only one I got pin wired to, so we'll just do this. Alright, that'll be fine. And do I have another one? Let's see if this blue one's got the right connectors on it. It's not about the journey, it's about how many times you stop at the bathroom along the way. You can maybe ask Steve Perry about that too, I suppose. I'm not finding the cable I was looking for here yet. Where is a cable with clippies? Yeah, you know what? We'll just clip it with something else. No, we won't. Won't open the cable box. Banana to gator clip. Where's the box for banana to gator clip? Not seeing it. No, but there's gator clip to gator clip, and that'll work. Okay. Let's connect up here. Okay, turn my load on. Let's give it current. 392. 400 milliamps. Yeah, that's good. So we have some math issues. Alright, so voltage, current. I think I knew that before. But the currents were always divided by 10. Let's upload that. Yeah, Adam, I've been sick, man. I've been off work since Friday. So hopefully, this is the longest I've gone without coughing my head off in 3 days. So That's just uploading, resetting. 0.44 MA. I mean, close enough for what we're doing. You know, and you can see that rail jumping around a bit. But you know, that's the point of this. That's exactly why this function exists. Optimization is possible in software. You know, depending maybe how quickly I query this or what. In fact, I'm going to look and see where my delays are at in here. I'm going to slow it down by half and see what happens. Basically, I'm checking it every half a second, and that's excessive to what I need here. At least at this stage. It's uploading. I like that better. I like that quite a bit better. I think this is one of those accuracy versus precision things. And I like that. That looks nice. So now we're going to think about, what do we need to do? Is this what we want it to look like? Do we want to do something else? That's beautiful. So let's think about it. Well, that whole purple. So we're showing voltages and current. I mean, we could make one say watts, just as math. Let's see here. Rail data. Oh, and actually, it looks like I already had some logic in there to do that at one point. I'm going to throw that. I'm going to turn that back on. Nitpick, you wouldn't use red. Red means error. Yeah, that's true. That could be a feature, actually, what you're talking about there. Colors. Here, let's switch back to this view so you can kind of see what I'm doing in code. Cyan. Let's do that. Max could be interesting. Ooh, okay, hang on. That was not at all what we wanted. Problem, I think, you know when I think I chose red is because I think white looked good on it. So I think I would need to go black and cyan. Let's do that. Well, and the beauty is, because this code's going to be available for everybody, they can implement features, you know, after the fact as well. The primary intent of this display is that of a voltage and current measuring device. However, it's not the only thing it can do. I've got some code to allow it to be a serial console, so you can monitor a UART. I thought that would be pretty useful, and that code did work. There's definitely some stuff going on there that we'll have to play with. Yeah, I don't like how that looks as good as I did. Maybe just both of the voltages in blue. What about this? Hang on. Black on green probably wouldn't look bad. Yeah, colors on sides aren't a bad idea. Black on green doesn't look terrible. At all. What if we do up here? Yeah, that black on green is cool looking. I don't think it's as cool as the white on blue, personally. Like that. That's gorgeous. I'm starting to think for base functionality that I'm just going to have that magenta not be there. We'll just hide that out for now and leave that as future expansion. Yes, I could combine the cells together. That is possible. Why is it mad about that? Oh, because I don't remember how to comment in Arduino. That's why. Yeah, I could definitely make that a thing, though. We can kind of draw whatever we want on this thing. Or we could stretch the existing fields and make things a little larger. I did some experimenting with that. That's not terrible. Okay, well, what if we do this? Let's see what this looks like. Trying to remember exactly how this works. Okay, why did that not work? Let's draw it as is there. Okay. Let's play with these numbers. See if I can remember what they mean. I feel like that might be height. Okay, okay. That's the starting height. Okay. So then 104, and then Alexa, what is 118 times 2?
118 times 2 is 236.
Okay, let's see what this looks like. And there's a space between them. $34. See if that's right. Good old pixel counting. Still not quite there. Okay, hang on. Maybe that way of doing math. Okay, there we go. All right, so I think the next thing I want to tackle is that negative issue. So in code, we're using a float type. But I want it to only be positive numbers. So I'm not sure what my options are for that, because nothing here will ever be a negative number. Arduino variable types. Let's learn about that real quick. So, float numbers. A float can store a negative or a positive float number. A double, 8 bytes instead of 4, so you can store bigger numbers. Integer is a whole number. Long is a bigger whole number. Yeah, so I think we're stuck with float, but let's see if there are any parameters. Nope, okay. Well, then we'll just do it with logic. I'm not sure exactly why I'm getting negative numbers, but really all I need to, I mean, it's 0 or negative 0. It's probably just the output from that module. But I think I just want to make sure that the number doesn't begin with a negative, because it's then what screws up my font and shoves it to that second line. And have current greater than or equal to 9, less than or equal to 9. I could probably do something like this. Let's display current. Let's display voltage. We just nest it up here. Fabs the value. I'm not sure what that does. Let me look into that. Takes a single argument. Yeah. So I'm a math idiot, so forgive me for asking what's probably a dumb question. An absolute floating value, is that always going to be positive? Does an absolute number make it required? Does it make it positive? Oh, okay. Well, that's exactly what I'm looking for then. That's easier than what I was getting ready to do. I was basically going to wrap all this and, if it's greater than, 0 logic, but I like that better. I like that a lot better. We decided against doing this, so that's gone. We decided against doing this. Okay. Save. And upload. The word fabs makes me think of the girl that did the DIY knitting machine stuff. That was her nickname. Okay. That's happier. Whitney, Fabienne, Sierra, something like that. I think she was German. She did some cool stuff. Knit Yak, I think, was her project. Okay. Let's see where this is going to go. 104, 240. Let's play with this. And something like that. I don't even know how it's going to fit. See if I'm anywhere close on my coordinates. Probably not. That's closer than I thought it would be. All right. Ooh, and that like almost fits. Okay, let's see here. Let's try something like that. We could also make this a header and do something useful with that. Like make it say voltage and current, real-time voltage and current, or something like that. And I think that people certainly would be able to hack on this. That's really cool. I gotta make this thing full screen so I can see it. Oh, that is beautiful. I think if I add a space there, actually no, I'll do this. Just make it 1 over. I can't tell if there are enough points there or not. If there are 2 or just 1 pixel to the right. Yeah, that's what I thought. Doesn't quite fit. Let's see what we can do. So we know current. 0. Actually, okay, so we can fit 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. We can fit 19 characters in there. Okay. So how about we do something like Real time power status. That's too many. That won't fit. Let's see what it looks like if we do something like that. For those of you just joining, welcome. My name is Josh and this is Project Blue Smoke Monster. We're working on a voltage and current sensor for a power supply I'm designing for a project of mine called the Microcontroller Trainer. And we are just seeing what we can do with a cool display and data, real time. Will rail fit in there? I don't think it will. Uploading. That actually looks really good. See what this looks like. From a logic perspective, this looks a lot like the old days of doing ASCII art and trying to fit things in a certain number of characters. Power rail status. So for me to move that to the top is a lot of work. The question is, do I do that? A lot of work. 2 characters to the left, 1 character to the right. You know, what I can do is this. Let's nudge it over just a little bit. The crazy thing is that this feature really drives up the cost of this power supply. Yeah, that looks nice. I think it's worth moving that to the top. Oh boy, this is going to suck. Okay, well, then here's what we're going to do. You think I leave it on the bottom? I think it's going to look more natural on the top. I don't hate the idea of that. Well, and here's the other thing. So let's get into that. Let's save it as it is. In fact, I'm going to do a save as. We're going to bring this up to the Trainer V3, and we'll call this Power Display Working. I'm going to just upload it one more time, make sure it looks normal. And I might actually show some serial stuff that I did. And you know, some added code I could create would be if the power rail is below, if it deviates 20% from the target voltage, turn the background red rather than blue. I'm not going to get into coding that right now, but I think that would be an easy feature to add. Okay, cool. Next is this. Let's upload it. Oh, interesting. Maybe I wasn't doing that with an ESP. I must have been doing that with an Arduino. Let's try something here. Just to see if it makes it compile. No. Okay, then. Well, if that wasn't what I was doing, now I do need to find this. Okay. ESP32 software serial. Ah. Does that do anything for me? And do I have to install it? Okay. Manage libraries. Okay. ESP. ESP software serial. Okay, install. Very cool. Okay. Let's see if that'll do its thing. Well, it must not be called that. Let's see what we got here. Examples. Get over there. See what it says over here. No, actually, it's just regular software serial. Okay. Let's check it there. Actually, I bet I did have it working, and the difference was I probably had the library installed. Okay, okay, we're getting there. Baud rate, yep. Serial speed. Verify. Okay, I don't remember that. Expected unqualified heat before. Oh, yeah, that looks like it's in the wrong place. Check it. Like I said, this worked a while ago, but it's been over a year. Okay, that may be extra. Let's check it one more time. That looks better. All right, and what you guys are missing here, I've got some software serial code. And the theory behind this was that we could use the display as a serial monitor. And this was kind of just meant to inspire people to experiment with this onboard microcontroller. It wasn't necessarily that you'd use this all the time, but you certainly could. We could put this in as a feature. You know, this TTGO display has built-in push buttons right on it. We could probably leverage one of those, I don't know, or tie a push button to a GPIO line. Yeah, that compiles. Okay, let's do this. You know, set the baud rate from the interface kind of thing. Auto baud discovery would be cool too. Okay. So there's that. Now let's see if anything does anything, because frankly, I don't remember how I built this. Okay, so baud rate on that's 9600, right? Yeah, so let's go here. Doesn't appear that that does anything. That's the display stuff. RX and TX. Now see, there says 115200. Okay, hang on. Let's make everything 9600 for now. I don't want to have to worry about differences in speed. In fact, I should do this. Let's make that constant.
Okay. That's 9600. And I don't see anything there. Get rid of that. So there's test serial and USB. That should print line. USB serial print line. Software serial test started. Okay. So the question is it doing that? Let's upload. Let's leave the serial console open. And we'll see what happens. I don't have a way within arm's reach to reboot the microcontroller to see that, so the upload's kind of the trick. There we go. Software serial test started. So I think what it would do at this point is on the serial pins, on USB serial, while USB serial is available, test serial write, USB serial read. So test serial write. So when do I go into the display? Wouldn't it be display.write? Something like that. Apparently I didn't save this when it was working. But hey, you know, baby steps. Come back to it 2 years later, you'll remember how it worked. Okay. Oh, there we go. Now we're getting some text. I'm trying to think the font size. I don't remember the command. Upload. Okay. Well, that kind of worked. Okay. Let's see what's happening there. Let's see what that does.
Thanks everybody that's watching. My name's Josh and this is Project Blue Smoke Monster. We're working on a microcontroller display that is being used on a power supply I'm designing for a few different purposes. Primarily voltage and current monitoring, but I'm playing with a little extra feature to allow it to be used as a serial monitor. Well, that didn't fit. $36, $240. Excuse me. Well, let me look at my other example here. When I do the power display stuff, displaying it. There's where we're doing the init for the display. Okay. That's backlight stuff. RSI rotation, we're doing the same thing. I did it up here, I think. Yeah, set rotation 3. I'll fill it with black. Display. Try something like this. Yeah, let's see what happens if we do that. So the idea was to allow this display to be toggled into a serial line monitor mode so that we could see a, a TTL level serial signal. Okay. While available, do. Yeah, there's something there I'll have to play with. Well, I'm not sure why that's not working, but we will play with that another day. Not really interested in fixing that tonight. Still being a little under the weather. But I think this is a lot of really good progress. Let me load that back up again, the other one. Which one? That. Just so we can show on the display the final progress of things. Boom. Upload. Let it do its thing. We'll make this thing bigger so that everybody can see what we've got going on. Yeah, that's weird because I know I had that serial display working. I remember doing it. So I'm sure we'll get it working again. So we're currently uploading. Uploading. Okay, there we go. Connecting. Took a little longer than I thought to compile there. But yeah, I think that's super awesome looking. I can't wait to see what we get community development wise from that. So power supply board's ready to go. We'll get that order placed. Probably here in the next 3 days. Probably gonna wait till payday, but we'll get that order placed. It'll come almost assembled from the boardhouse. We'll add the power switch, the shunt resistors, a couple of connectors, and then the microcontroller. And we should be able to fire up the power supply. I mean, all this data is coming right off of it as is, so I think we're in it to win it, guys. So things that are left. We need to bring this power supply board to final design, which I think we're really close to by calling it release candidate 1. You know, that makes it, you're almost there when you call it something like that. We will be, when the new boards arrive, we'll test it, we'll measure it, we'll try to kill it. I think we've covered most of those bases so far. We may add some mechanical stuff to it because we're gonna want to set it up on standoff so it can mount to the other board. In fact, I wonder what the easiest way to do that is. So if I go to the schematic here, we know that this goes away. We know that this goes away. That's fine. We know that all of this goes away. I wonder what the easiest way is to overlay that other board here. I mean, I fought through it last time, you know, getting positioning just right of all these holes, but we were taking up this whole half side of the board. So this thing's going to be pretty small and condensed into this upper quarter. We're still going to need to do a little playing with this Digilant 82 connection that we've got in here. In fact, I can see that there's some problems there, but we're not spinning this board yet. So close, you guys. Just I don't know. Just so close. We've got to get this thing across the finish line because I want to start playing with this thing. I love some of the things we've done down here, adding these user LEDs. I'll tell you what's really almost next. Since I've decided that this is not going to be a kit, this is going to sell as a finished product, I need to get these things converted to surface mount. I wonder how much effort that's going to be. Like this thing right here. So if we go in here, and we know, let's see, I'm going to change footprint here. So it's currently 2.5 millimeter pin header. Really, it's just that changes. And the question becomes, how big of a giant pain in the butt is that going to be for me? And actually, let me change my grid here. Nope, bigger, smaller grid. Better. I don't think that's going to be a giant pain in the ass at all. I mean, yeah, I've got some traces to monkey with, but I don't think that's going to be a complete trip to Suckville. I'm a little worried about strength, I'll be honest with you. But that's mostly paranoia. That's not because I don't think these will be strong enough. I think it's going to be plenty strong enough. So yeah, so I think that's the next exercise on the trainer board is let's get standardized on what headers we're going to use. Let's convert them from through hole to surface mount. Let's get some actual pin counts. If I need to add some ground pins to, make them a readily orderable size, we can, because we're not going to have people breaking headers apart and doing all that. This thing's going to come ready to rock. I really don't want the user to have to do any assembly to use this. I want it to be plug in and go. Because after all, this is all about creating a STEM tool that students can use, and they're not going to want to whip out a soldering iron to get this thing going. That's one of the lessons I learned from the early run. But yeah, very cool. Very cool. When we get the hardware side of this done, I'm going to need to sit down, and maybe I'll brainstorm some of this on stream, but I need to come up with 101 projects that this thing can do, because that's really what we're proposing here. I want a development environment, a learning environment that you can do 101 things with, as close to out of the box as possible. I know that's not a super realistic goal, but I think with minimum support components, we should be able to get there. Whether that's bundling this with one of those, prefab commodity sensor kits or whatnot, I think we can come up with 101 project ideas. That would be sweet, would it not? All right, guys. Well, I think that's all we're going to do for tonight. I appreciate you riding along as we experiment and figure out what's possible. I think this is going to be a lot of fun. A lot of fun. Heck, you didn't even get to see the little piece of this I wanted you to see right here. I threw this in. I was talking about it. Nobody told me I forgot to share it. That's the surface mount part. So I'll give you a 3D render of that. So yeah, I'm a little scared about mechanical stability of that, but we'll see. Other people use them. I'm sure it's fine. All right, with that, I'm going to say thank you. Enjoy the rest of your evening, wherever you might be, and we'll see you next time. My name's Josh. Thanks for watching Project Blue Smoke Monster.
Holy crap, did it just desolder itself? I think it's desoldering itself. One end of the coil goes to the antenna connector jumps to the diode. The diode is our audio path, and this comes out to the headphone. One of these days I'm going to fix the squeaky chair on the screen. So if you want one of this rev, it's available to ship now. Oh yeah, can't do that here. Can't do that here. Gotta do that in the other cart. Boy, I've got that heat sink hot. Like hot. Like feeling hot. I mean, this is not going to be a showstopper that stops me from developing this. If I got to deal with a line of garbage for this badass capability, I'll deal with a line of garbage. And the Microcontroller Trainer is a learning environment, experimentation environment, development environment. You come up with what you want to call it.